Hi guys, so today we're going to take a look at question 2 from paper 1 of the 2016 exam. Okay, so we want to find the range of values of x for which x, the magnitude of x minus 4 is greater than 2, where x is real. Okay, so our equation is x minus 4 is greater than 2. Okay, well, what does that mean? Well, it can mean that either x minus 4 is greater than 2, or x minus 4 is less than minus 2. So if it's less than minus 2, then that would be values like minus 3, minus 5, minus 100, and all of those have magnitude greater than 2. Okay, so let's just work with this side for now. Now, when is x minus 4 greater than 2? Well, if we bring the 4 over, then it's when x is greater than or equal to 6. Okay, and now if we work on this side of the equation, well, when is this? Well, this is true if we bring the 4 over. This is true when x is less than or equal to 2. Okay, so if x is greater than 6 or less than 2, then this is true. So this is kind of just your answer. So the range of values for x is x greater than 6, and you could even just write this in kind of like a set notation. So we could say x greater than 6 union x less than 2. Or you could just say when x is greater than 6 or x is less than 2. Either ways of writing that are fine. Now on to part B. We want to solve the simultaneous equations x squared plus xy plus 2y squared equals 4, and 2x plus 3y equals minus 1. Okay, so there's kind of two main ways of going about a simultaneous equation. And one is to kind of cancel. So let's say we had like ax plus by equals 6, and cx minus by equals 10. Now, we might just add these together, or we might try and manipulate our equations to look like this, and then add them together, and then we would get something like a plus c times x equals 6 plus 10. And then we could solve for x. Or the other way of doing it, which amounts to pretty much the same thing, is to write x in terms of y. So let's just say a over b y, and then insert this value of y, insert this value of x into your other equation, and then you're going to have an equation that's just in terms of y, and then you can solve it. Now, this first method isn't going to work with this kind of equation because one of them is a quadratic and the other is a linear. So we're going to have to use the first method. So we're going to have to write x in terms of y. And now it would be, so if we just write down our equations, x squared plus xy plus 2y squared equals 4, and 2x plus 3y equals minus 1. It's pretty clear which equation it would be easier to write x by itself, and that's the second equation. It would be very difficult to write the first equation just in terms of x, and it might not even be possible, but it's definitely possible for the second. So if we just bring the 3y over, we get 2x equals minus 3y minus 1, or x equals minus 3y minus 1 over 2. Okay, so if we go back to our first equation and we put in this value of x whenever we see x, we get x squared, which is just minus 3y minus 1 over 2 squared, plus xy, which is just minus 3y minus 1 over 2 by y, plus 2y squared equals 4. And now if we work this out, we'll get 3y minus 3y minus 1 squared, which is just 9y squared plus 6y plus 1 all over 2 squared, which is 4, plus, or just, actually, we can write this as, we can take the minus out of the minus 3y minus 1 because it's common, and we get minus 3y squared plus y over 2, and then just plus 2y squared equals 4. And now we have something that's starting to look like a quadratic, which we know we can solve. So if we just try and finish cleaning this up, if we collect the y squared terms together, then we get 9y squared over 4 minus 3y squared over 2 plus 2y squared. Then if we collect the y terms together, we're going to get plus 6y over 4 minus y over 2. And then if we have our constant, if we bring our constant over, we'll get plus 1/4 from the first fraction, and then minus our 4, minus 4. And then this will equal 0. Okay, so let's clean this up. So 9 over 4 minus 3 over 2 plus 2 is 3 over 4 plus 2, which is 11 over 4. 11 over 4 y squared. 6y over 4 minus y over 2 is just y. And then 1/4 minus 4 is just minus 15 over 4 equals 0. So we could kind of simplify this further just by multiplying across by 4, and we'll get 11y squared plus 4y minus 15 equals 0. So now we have a quadratic equation, and we know how to solve a quadratic equation, so we'll just immediately write down our minus b formula. So x equals minus b plus minus the square root of b squared minus 4ac all over 2a. Okay, so in this case, a equals 11, b equals 4, and c equals minus 15. Okay, so let's just plug these values in, and we get x equals minus 4 plus minus the square root of 4 squared minus 4 by 11 by minus 15. All over 2 by 11. And the two values we get here are x plus and x minus, which are 1 and minus 15 over 11, if you just plug that into your calculator. Alright, sorry. So this is This is y we're looking at. Okay, so these are the two values of y that will work. And now, for each of these values of y, what is x? So for y plus, x plus equals, and then we just plug in 1 into our formula for x, minus 3 by 1 minus 1 over 2. And this is just minus 2. And then if we plug in minus 15 over 11 into y, we get minus 3 by minus 15 over 11 minus 1 all over 2. And this is 45 over 11 minus 1, which is 34 over 11 over 2, is just 34 over 22, or 17 over 11. And so our two solutions are x plus y plus and x minus y minus, which gives us minus 2, 1, and 17 over 11 minus 15 over 11. And now if you want, and I think that this would probably be a smart thing to do if you have the time, I would just plug both of these values into your simultaneous equations, and just to make sure that they work out. That's a great way of making sure that you know you got the right answer, especially with these simultaneous equation type questions, or really any type of question where they're asking you to solve an equation. If you plug your answer into the equation and you get the right answer, then you can be very confident that you're correct.